Welcome back. The application's rotation button cycles through 4 angles which are passed to a polygon function. 2 additional parameters are passed to the function. A 2-dimensional array which represents the vertices of the polygon, aka points, and a scaling factor. Now lines are assumed between the elements of the array and also between the last element and the first element, the definition of a polygon. In this specification, the origin is assumed to be at the middle of the left-hand vertical line. Now, if you take a careful look at this, it does not fit within a 1-by-1 space. It's scaled. It's scaled by a scaling factor. Now, the width of the polygon, as shown, is 3 units. But its origin is at its left-hand side. So the scaling factor is 6. Let's take a look at some code. The polygon function makes use of a low-level structure which is defined in the point and line 2D file. I haven't covered this yet. There's an x and y coordinate, and the reason it's world is because the point may be outside a normalized 1-by-1 space. The structure has a function called transformation, and the purpose of that function is to scale and rotate based on an angle, and it returns a normalized point. First thing it has to do is convert the angle to radians and calculate x and y of the normalized point. Now the equation, the first part, the cosine and sine functions, which are both in x and y, are actually what is referred to as 2-dimensional rotation affine transformation. Okay, that's the technical term for it. I'm not going to derive that because this isn't a mathematics course. This equation is easily available on the internet, for example. It then is divided by the scale factor, so that puts the point back into the normalized space, and then there's an offset to take care of the fact that the origin is in the center of that space. And then the point is returned. Let's go on to the polygon function. As indicated earlier, the polygon function takes 3 parameters. There's a 2-dimensional array which represents the vertices. There's a scale factor and there's a rotation angle. Now the first thing that happens is there's the creation of an empty array of P2TD points, normalized points. There's a loop that runs through all the vertices. The x component of the world point is determined and the y component. Now it's casted to a w because by convenience I just simply define the array in integers. It was easier to think about it. So now I have a world point. I want to transform that to a normalized point. So I need a scale factor and I need a rotation angle. And that point is appended to the array of normalized points. Now at the end of the loop, I want to make this a polygon. And the way I'm going to do that is I'm going to simply connect the last point to the beginning point. Okay, I'm going to append the beginning point. Now at this, I want to generate lines because that's what the low-level code wants. I'm going to loop through the normalized points that I just created. And I'm going to form a line. Well, I'm going to begin the loop at the first element of the array. In other words, it's 1 in because the array starts at 0. The line is going to be formed by connecting the previous point to the current point relative to the I variable in the for loop. That's it. That completes the drawing for the polygon. Let's move on to triangles. These recursive triangles. I've modified the integer, which is passed to each incarnation for exploration purposes. 2, 3, 5, 7, back to 1. 1's not all that interesting. It's just a single triangle. If I go to 2, you may wonder, what is this? Is this a triangle with an embedded upside down triangle, or is it two triangles supporting an upper triangle? The way the algorithm works, it's actually 2 supporting 1. There's a lower left, lower right, and an upper. If I go to the next, things get embedded. We have a lower left with 3 triangles within, same on the right-hand side, and same on the top side. I'm going to go to the code. I'm going to introduce it, and then I'm going to jump back to diagrams to explain the algorithm. The function that actually adds the lines to the lines array is called embedded trig, for embedded triangles. It takes 2 points to represent the base of the triangle, a double which represents its height, and a level. Now, there's a start function, which is simply start recursion. This is the one that the high-level software calls as a result of the button pushes. And the integer that is currently being used is passed to it. It kicks off the start process by specifying a triangle, which is the first triangle, which simply has a base and a height, which pretty much fills the entire view area. Now, the embedded trig function is really divided into 2 sections. There's code that is executed if the level passed is 1, and there's the code executed if the level is greater than 1. Now, when it's a case of just 1, the upper part, the 3 lines for the indicated triangle are added to the lines array. And there's just some calculation here, and you'll see three appends of the lines. Now, if that number is greater than 1, there's something that very different happens. 3 smaller triangles are generated. There's a lower left, there's a lower right, and there's an upper triangle. This function calls itself. It's recursive. And when it does that, it subtracts 1 from the level. Now, what I'm going to do is I'm going to jump back to a diagram, and I'm going to describe how the algorithm works, because it's not obvious from looking at this code. Value is 3. When the function gets entered, that value 3 is not the first half of the function, it's the lower half. And what ends up happening is 3 triangles are created, but the first one, the one on the left-hand side, is defined, and embedded trig is called again. It's called with 1 less than 3, which is 2. So it means that the whole process will happen again. The lower left-hand triangle will be processed, and it then, in turn, the embedded trig function will be called again. But then, at that point, the value is then 1. So then the outer lines will end up being added to the lines array. It returns, and at that point we're still 2, so we're going to move on to the lower right-hand triangle. Invoke again, the level will be 1, so that triangle gets drawn. The same process happens for the upper one. Now when you bounce back up, you're back to 3. Now at that stage, because you've already done this one, you're going to go do this one here. And the same recursion will happen. Once that happens, then the third one will get drawn. Same thing happens if you up the level. And you can see the pattern here. In actuality, the lines for the first triangle that are actually added to the lines array is the one all the way down on the left-hand corner, followed by the one to the right of that, followed by the one above that. And this whole process continues. Now, if you're confused, I'm not surprised. It's going to take a little bit of mental energy to get your mind around this. Before we move on to the next video, I'd like to tell you about my other YouTube channel called Touch Netcast. It covers the development of iOS applications. Now, the reason I'm pointing this out is that there's 6 episodes on the Swift programming language, and there's discussion of recursion in some of the later episodes. Videos to this channel were added over the course of a couple years, so some of the information on iOS development is somewhat out of date. However, the overall concepts are still the same. Let's move on to the next video.